An SSD, or solid-state drive, is a type of storage device used in computers. This non-volatile storage media stores persistent data on solid-state flash memory. SSDs replace traditional hard disk drives in computers and perform the same basic functions as a hard drive. But SSDs are significantly faster in comparison. With an SSD, the device's operating system will boot up more rapidly, programs will load quicker, and files can be saved faster. A traditional hard drive consists of a spinning disk with a read-write head on a mechanical arm called an actuator. An HDD reads and writes data magnetically. The magnetic properties, however, can lead to mechanical breakdowns. By comparison, an SSD has no moving parts to break or spin up or down. The two key components in an SSD are the flash controller and NAND flash memory chips. This configuration is optimized to deliver high read-write performance for sequential and random data requests. SSDs are used anywhere that hard drives can be deployed. In consumer products, for example, they're used in PCs, laptops, computer games, digital cameras, digital music players, smartphones, tablets, and thumb drives. They're also incorporated with graphics cards. However, they are more expensive than traditional HDDs. Businesses with a rapidly expanding need for higher input or output have fueled the development and adoption of SSDs. Because SSDs offer low latency than HDDs, they can efficiently handle both heavy read and random workloads. That lower latency stems from the ability of a flash SSD to read data directly and immediately from stored data. High-performance servers, laptops, desktops, or any application that needs to deliver information in real time can benefit from solid-state drive technology. They can also help to alleviate boot storms with virtual desktop infrastructure or inside a storage array to store frequently used data locally using a hybrid cloud. How do SSDs work? An SSD reads and writes data to underlying interconnected flash memory chips made out of silicone. Manufacturers build SSDs by stacking chips in a grid to achieve different densities. SSDs read and write data to an underlying set of interconnected flash memory chips. These chips use floating gate transistors to hold an electrical charge, which enables the SSD to store data even when it's not connected to a power source. Each floating gate transistor contains a single bit of data, designated either as a 1 for a charged cell or a 0 if the cell has no electrical charge. SSDs use three main types of memory: single, multi, and triple level cells. Single level cells can hold one bit of data at a time, a 1 or 0. Multi-level cells can hold 2 bits of data per cell and have a larger amount of storage space in the same amount of physical space as an SLC. Triple-level cells can hold 3 bits of data in a cell. Although TLCs are cheaper, they also have slower write speeds and are less durable than other memory types. Several features characterize the design of an SSD. Because it has no moving parts, an SSD isn't subject to the same mechanical failures that can occur in HDDs. SSDs are also quieter and consume less power, and because SSDs weigh less than hard drives, they're a good fit for laptop and mobile computing devices.